I am Neha. Our ATC assignment project is to design and implement a lexical analyzer and phaser for many ATC language using infinite automata and context-free grammar. Objective: to design a lexical analyzer that reads mini ATC language input and converts it into meaningful tokens like keywords, identifiers, numbers, and symbols. To perform syntax validation and detect errors in ATC commands like incorrect structure or missing elements. To build a simple and efficient system that demonstrate programming languages are processed in real-world compilers. Introduction: in modern computing system, programming language requires structured processing to convert human-readable instructions into machine-understandable forms. This process is carried out by a compiler, which consists of multiple phases such as lexical analyzer, syntax analysis, and systematic analysis. Among these, the lexical analyzer and phaser form the foundation of compiler frontend. Mini ATC language. Mini ATC language is simplified formal language designed to demonstrate concept from automata, theory, and computation. It is mainly used for academic purpose to understand how languages are defined, analyzed, and processed by machines. The language consists of limited set of symbols. First one, keywords, identifiers, numbers, and special symbols. The lexical analyzer scans the input and converts it into tokens using automata. Lexical analyzer and phaser diagram. Lexical analyzer, it reads the source program characters by character and convert it into tokens. Tokens are meaningful units of the program. Working of lexical analyzer. It reads the input program, identify the keywords and identify the identifiers, and identifies the numbers and operations and generate tokens. Next, phaser. The phaser checks whether the tokens follow the grammar rules of many ATC language. It verifies the syntax correctness of the program. Working of phaser. It receives the tokens from lexical analyzer, matches tokens with context-free grammar rules, checks the correctness of the syntax, accept or reject the program. Tokens and rules. Tokens are the smallest meaningful unit of the program. Token types: keywords, identifiers, numbers, operations, and delimiters. Example of the keywords are begin, end, front, print. Example of identifiers are X, numbers 10, 20. Operations are plus, minus, multiplication, equals. Rules for identifiers: it must starts with a letter, can contain letter and digits. Special symbols are not allowed. Identifier DFA. Here we have a DFA. The starting state is Q0, final state is Q1. Transition table Q0 Q0 comma A is equal to Q1. The DFA accepts all the string that end with A. From Q0 input, it moves to the final state Q1, and Q1 input it keeps in the Q1. If the string ends in Q1, it is accepted, otherwise it is rejected. DFA for numbers. A number consists of one or more digits like 0 to 9. Here we have a DFA. Here Q0 is a starting state and Q1 is a final state. The DFA accepts one or more digits. Input must start with a digit, otherwise it is rejected. It ensures at least one digit is present. It is used in lexical analyzer to recognize number tokens. Example for valid strings are 5, 122, 123, etc. Invalid strings examples are A, 12, etc. Regular expression. Regular expression is a pattern used to describe a set of strings and it is widely used in lexical analyzer. Regular expressions are basic operations like union, concatenation, and clean star. Regular expressions represent regular language which can be recognized by finite automata. Implementation. The mini ATC implementation consists of two parts: lexical analyzer, phaser. The analyzer identifies tokens from the input program. The phaser checks whether the program follows the grammar rules. Steps in the implementation are: read mini ATC source code, split the program into tokens, classify tokens, apply grammar rules, display valid or invalid program. Expected output is the program is systematically correct, and example for invalid output is syntax error. This is our code. Here import RE module. RE means regular expression module in Python. It is used to find tokens such as keywords, identifiers, numbers and symbols from the mini ATC program. Program is equal to begin index x is equal to 10 till end. This is the input mini ATC program. The program starts with begin and ends with end. Here int x is equal to variable declaration, x is equal to 10 assignment statement, and print x is equal to print statement. Next, lexical analyzer. Token is equal to re find all. Here, the lexical analyzer breaks the program into small meaningful units called tokens. Next is the printing statements of the tokens. This loop prints each token one by one. Next, phaser output. Here the phaser checks whether first token is begin and last token is end. If both are correct, the program is valid. If both the tokens are correct, the program syntax structure is valid. Checking for declaration statements. Checks whether the declaration keyword int is present. Checking the assignment statement. Checks whether the assignment operator is equal to is correct. Checking print statement. Checks whether the print statement is exist. Next, this is the output. Here the lexical analyzer separated the program into tokens. The phaser verified correct program structure, valid declaration statement, valid assignment statement, and valid print statement. This is the execution of the code. This is the output. Next is the test cases. Valid test case. Input is equal to begin int x is equal to 10, print x end. Here the expected output is the program structure is correct, declaration statement is correct, assignment statement is correct, and print statement is correct. Mini ATC program is systematically correct. Invalid test case is input is equal to begin int x is equal to 10, print x end. Expected output is syntax error. Conclusion. The Mini ATC project helped in understanding the fundamental concepts of automata theory, lexical analyzer, and phasing. In this assignment, a simple lexical analyzer and phaser were implemented using Python to verify a Mini ATC program follows that given context-free grammar. The lexical analyzer identified tokens such as keywords, identifiers, numbers, operations, and decimals, while the phaser checked the syntax correctness of the program. The project demonstrated how the programming languages are processed in compiler design and showed the practical application of finite automata and grammar rules. Thank you.